students, we are in the lesson integers. Okay, so now let us move with the properties of addition and subtraction of integers. Yes, in the last class I taught you how to represent integers on the number line. Yes, and how to compare the integers, isn't it? And how to arrange them in ascending and descending order, right? Okay, now let us go for the properties of addition and subtraction of integers. So what are these properties? All these properties you learned in 6th standard. Which are those properties? Do you remember? Yes. So while learning the lesson whole numbers, yes, you learned some properties like closure property, commutative property, associative property, and again distributive property. Yes. So all those properties will check for these integers. Yes, whether all those properties holds good for integers or not. Yes, let us see them one by one. We'll go only for addition and subtraction now. Yes, the first one will be the closure property. Closure property of addition. What is this closure property of addition? Yes, so you have seen that when you add whole numbers, what is the answer you are going to get? Yes, when you add whole numbers, the answer you are going to get is again a whole number, isn't it? So this is what the closure property says. What does closure property say? The sum of any whole numbers is again a whole number, right? Now we'll apply this for integers, whether the sum of any two or any integers is again an integer or not, we have to check. Okay, we'll take some examples, and I want to take -1. This is what? Closure property of addition. -1 plus 2 is equals to -1 plus 2, then I will take 7 plus 5. Yes, -3 plus of -3. Yes, 9 plus of -6. Yes, let us check the answer. -1 plus 2. What is -1 plus 2? See, different signs, subtract. 2 minus 1, 1. Bigger number is having positive sign, so answer is positive. 7 plus 5 is 12. Yes. -3 plus of -3. See, -3 as it is, plus into minus is minus. 3 is equals to. -3 as it is, plus into minus is minus. 3, both are having same sign, so add. So 3 plus 3 is 6. Both are having same sign, so answer is -6. Now 9 plus of minus 6 is there, plus into minus is minus. 9 minus 6 is equals to. What is 9 minus 6? Yes, of course it is 3. Now if you see the answer, 1, 12, -6 and 3 are always integers. See, is 1 an integer? Yes, of course it is an integer. It is an integer. Then what about 12? Yes, 12 is also an integer. -6, is -6 an integer? Yes, it's a negative integer. So -6 is again an integer and 3 is an integer. Yes, so closure property of addition holds good for integers. Are you getting? So here it is understood that the sum of any integers, if you are taking, here we have considered only 2 integers. If you are taking more than 2 integers, if I take -1 plus 3 plus 4 minus 9, then what is the answer? Let us check. -1 plus 3 is 2, right? 2 plus 4 is 6. 6 minus 9 is -3. Yes, -3 is an integer, right? Yes, -3 is an integer. So you can take many integers, and if you get the sum of those, you get that the sum of any integers is again an integer. Yes, the sum of integers is again an integer. That is nothing but the closure property of addition. Yes, okay. So in general, for any two integers Yes, for in general, for any two integers a and b, a plus b is an integer. So if you are taking a plus b plus c plus d, a plus b plus c plus d is again an integer. Getting? Okay. So now let us move for closure property of subtraction. Okay. So what does closure property of subtraction say? It says that, yes, closure property of subtraction. Let us see whether the difference of any two integers is again an integer or not. Okay? Yes. We'll take 8 minus 9. Yes. Minus 3 minus of minus 6. Minus 12 minus of minus 1. Yes. We'll take 15 minus 10. If you observe, here we are considering only the subtraction. Yes. 8 is an integer, 9 is an integer, minus 3 is an integer, minus 6 is an integer, minus 12, minus 1, 15, 10. Here we are taking the difference of two integers, isn't it? Now, what is the difference of 8 and 9? See, the answer what you are going to get after subtraction is the difference. The answer what you are getting for addition is the, yes, it is the sum of two numbers. Yes, the answer what you are getting is sum. If you add the numbers, the answer is called as sum. If you subtract, the answer you get is the difference. Yes, if you multiply the numbers, the answer you are going to get is the product. Right? If you divide the numbers, the answer you are going to get is the quotient. Sum, difference, product, quotient. Yes? Then, what is 8 minus 9? 8 minus 9. See, both are having different sign, so subtract. 9 minus 8 is 1. Bigger number is having negative sign, so minus 1. Minus 3. Minus into minus is plus 6. Yes? Minus 3. Minus into minus is plus 6. Different sign, subtract. 6 minus 3 is 3. Bigger number is carrying positive, so answer is positive. Now, minus 12 plus 1. Why it is plus 1? Minus into minus is plus, so minus 12 plus 1. Different sign, subtract. 12 minus 1, it is 11. Bigger number, negative. Yes? 15 minus 10, different sign. Yes, subtract. 15 minus 10 is 5. Bigger number positive, so it is plus 4. Now, if you see the difference of two integers, you see that minus 1 is an integer, right? And 3, minus 11 and 5, all these are integers, isn't it? So here we say that integers are closed under subtraction. Integers are closed under subtraction. Okay. Integers are closed under subtraction. Yes, integers are closed under subtraction. So in general, wait, for any two integers, a and b, for any two integers a and b means a is one integer, b is another integer. Are you getting? For any two integers a and b, a minus b is an integer. Yes? What is this a minus b? If you are considering a as 8 and b as 9, the difference we are going to take, the answer is minus 1 here. Therefore, the difference of a and b is again an integer. Yes? For that closure property of addition, I forgot to write this line. Integers are closed under addition. For that addition, write it. Are you getting? So, this is in general for any two integers Yes, it is commutative property of addition. What is this commutative property of addition says? For whole numbers, you know that if you are taking two integers as a and b, and if you change their order, yes, if you are taking 3 and 2, the sum of 3 and 2, 3 plus 2 is equals to 5. That is equals to 2 plus 3 also. Yes, let me take the numbers here. 3 plus 2 is equals to 5. Is it okay? Is it right? Yes. 3 plus 2 is equals to 5. That can also be written as 2 plus 3. This we all learn for whole numbers. Because 3 and 2 are whole numbers. Here the general statement was that a plus b is equals to c, that is equal to b plus a. Yes, in general we were writing a plus b is equals to b plus a. This is for what? This is for closure property of addition of whole numbers. Right? Now, let us see whether this works for integers or not. If you see 3 and 2 are there, I will interchange their places, I will change their order. Yes? 3 plus 2 is 5, 2 plus 3 is also 5. Yes, if we take some integers, now I want to take minus 5 plus 9 is equals to, what is minus 5 plus 9? Different sign, subtract. 9 minus 5 is 4, bigger number is carrying positive sign. Now, I want to change their places, 9 and this is minus 5. Yes, this is plus of minus 5. See, I considered A as minus 5 and B as 9. Yes, now I want to substitute these two numbers in the form of this. I am going to check whether these two are equal or not. Okay? Now, 9 plus of minus 5 is 9. Plus into minus is minus 5. 9 minus 5 is what? 9 minus 5, of course it is 4. That implies, yes? What it implies? It implies that 9 plus of minus 5 is equals to minus 5 plus 9. Yes, both are same thing. This is a plus b is equals to b plus a. Yes, so that implies a plus b is equals to b plus a. So for this, what you are going to write? We will take some more examples. Yes, that's all right. No need to write this. Okay. B plus A is minus for the commutative property of addition. Are you getting? So in this, this is what? In whichever order you add, in whichever order, yes, it may take first place or it may go for the second place, or whichever place, just you shuffle the numbers, the sum what you are going to get is the same. Yes, let us check this for the subtraction. Okay, then what does the commutative property of subtraction says? Let us see. Commutative property of subtraction. Yes, so the earlier one, commutative property of addition, make it as the Roman number 1. Okay, and this is in second one, this is Roman number 2. That is commutative property of subtraction. Yes, so in this commutative property of subtraction, let us see if we change the order of the integers, whether the difference is same or different. Let us check. Okay, so now if you are taking that is 5 minus 9. Yes, what is 5 minus 9? I will consider A as 5 and B as 9. Okay, 5 minus 9 is, this is both are having different sign. 9 minus 5 is 4. So bigger number is carrying negative sign. It is minus 4. I have considered here A as 5 and B as 9. Now I want to change their places. I want to take 9 minus 5. See, this is A minus B, this is B minus A. Yes, now 9 minus 5 is there. The smaller number is carrying what? It is carrying negative sign. 9 minus 5 is 4. Bigger number is having positive sign. This implies minus 4 is not equal to 4. Yes, minus 4 is not equal to 4. Therefore, 5 minus 9 is not equal to 9 minus 5. Yes, we will take one more example. Yes, 13 minus of minus 2. See, where 13 is A and minus 2 is B. Yes, 13 is A, minus 2 is B. A minus B, that is equals to, see, 13 as it is, minus into minus is plus. It is plus 2. What is 13 plus 2? 13 plus 2 is, of course, it is 15. Right? 15. Okay. Now, let us change their order. Yes. B is minus 2. Then, what is A? Yes, it is minus because we are taking the difference of those two. Minus 2 minus 13. Yes, this is B minus A minus B minus A. Both are having same sign, so add. Yes, 13 plus 2 is 15. Yes, both are carrying same sign, so the answer is also minus 15. Yes, now if you compare the difference of those two, 15 is not equal to minus 15. Yes, 15 is not equal to minus 15. That implies 13 minus of minus 2 is not equal to, this is not equal to minus 2 minus 13. See, A minus B is not equal to B minus A. Yes. So in general what we can write? In general, or commutative property of subtraction holds good for integers or not? If A minus B is equals to B minus A, then we would have written the subtraction is commutative for integers. But here the subtraction is not commutative for integers. Yes, subtraction is not commutative. Subtraction is not commutative for integers. Yes, in general, for any two integers, A and B, for any two integers A and B, A minus B is not equal to B minus A. Yes, so this is the general statement can be given to the commutative property of subtraction. Yes. So here it is clear that addition is commutative for integers. Addition is commutative for integers. It means that a plus b is equals to b plus a. But subtraction is not commutative for integers. Are you getting? We are studying two properties, that is closure property of addition and closure property of subtraction, commutative property of addition and commutative property of subtraction. It is clear that the integers are closed under addition and subtraction. Integers are closed under addition and subtraction because the sum or the difference of any two integers is again an integer. But the addition is commutative for integers, but subtraction is not commutative for integers. Yes. So in the next class we'll move with associative property. Okay. So next is associative property. Be ready with, just go through with the associative property that is given in your textbook. And before I tell, I want you to give the answer. Yes. Are you getting? Okay. Thank you.